if the tilt sensitivity was too jumpy, did you consider linear interpolation to reduce the huge jumps in tilt angles?
I did, yes, yeah. And one of the things that I wanted to say about the project is that I intentionally kept it, fairly simple. And something I've learned recently is sometimes it's quite nice to provide the basis of a project, and then publish it on GitHub, and then say to people, look, you could do all these things to it. Why not contribute to it? So whereas before I would probably make, a package really, really complete with all the features in, what I've started to do recently is to try and say, well, actually, there's all these things that we could work, collaborate on and perhaps do together. So the in the notes that you can find on the GitHub page, it tells you where the code is that you load onto the Microbit. It's just a MicroPython program. There's some very, very simple filtering in it. It is, just the dead zone. But the idea is that that's where you go to make the changes. And if lots of people say, oh, we'd really like this feature, then log them as issues and I'll have a go at doing it. If you want to join in and do those yourself and, send a pull request, that's another way of doing it. Yeah. But there's a ton of stuff you can do at the Microbit end now because the logic isn't on the Pi. The logic is on the Microbit that you hold and you tilt. It means that you could actually have a few of these in your pocket and, set them up differently and try them out differently. So, but yeah, linear interpolation and various forms of filtering, there's enough memory still left on the Microbit to do quite a lot of that stuff. Yeah. And I think, just taking a leaf from, I forget who it was talking about testing earlier on in one of the talks. It was probably Dr. Footleg, but test, and get some feedback on what works and what doesn't. Is a way to do that, I think.
Yeah. So the bit where you do use Bitio to pair the device, did you write that bit, or is it part of Bitio that does the pairing?
Oh, right. Yeah, so I wrote that bit, and there's a tiny bit of history in that when Martin O'Hanlon and I wrote the Adventures in Minecraft book, we originally wanted a physical computing chapter, which is really easy to do, of course, on the Raspberry Pi because you just use RPi GPIO. But we the publishers wanted us to also do the physical computing on Mac and Linux and Windows. So we chose a little Arduino platform, and I wrote a library then called NEIO, which basically was RPi GPIO, but on an Arduino. And a good friend of mine, Sukin Pang, he helped us with the preloading the firmware and giving so that people could actually just just buy off the shelf. That worked really, really well. So thanks Sukin for all that help. What we did when we did the second edition of the book was I said, oh well, Microbit is a really good way of doing this platform. So I changed from NIO to Bitio. So we basically used the same code, but then just made it a bit more Microbit friendly. Since then, I noticed that our good friend Nicholas Tollerby, built in a piece of code into Mu that uses the device ID that comes from the USB. So I'm considering upgrading Bitio to use that same scheme. So it basically scans the USB bus, and you get these ID numbers that come back that tell you it's a Microbit. And then you don't have to do all that plugging in and plugging out. So yeah, that's on the list. It's on the Bitio list. It's a good thing.
For Bitio, did you ever think about using the USB device ID when you're looking at which port you're looking at?
Not specifically. I mean, there's Pi Serial, and I think this came a bit later after we did the work. Pi Serial gives you a way to get at that information. So, right. So USB has a thing called a VID and a PID, a vendor ID and a product ID, which is, I think, that device ID that the questioner is asking about. And that's unique to the Microbit. But I'm pretty sure that came in later versions of Pi Serial. So the time when I originally wrote the stuff for the book, it probably wasn't available. And I think it was Nicholas that discovered an easy way of doing that.
Right. Thank you. Next question is, with Modern Pi with Bluetooth, can it be done with one Microbit only?
Modern Pi with Bluetooth.
So Modern Pi's have Bluetooth.
I see. So rather than using the radio to a Microbit, effectively it's like making one half of what Martin did with the blue dot. Yes, most likely. That's a good point, actually. That might work. In fact, there might be some. I'd have to check what's. I know Martin was saying he uses OFCOM. I'd have to check exactly how the blue dot works, but it's possible you could use the existing Bluetooth that the Microbit supports to talk to blue dot code at the other end. That might work. It might be an interesting way of doing it, actually.
Yeah.
So yes. So the modern Pis have Bluetooth on board, and the Microbit supports some Bluetooth peripheral modes. So, yeah, that's a good point, actually. I'll have a little think about that. That'd be a good little addition.
The store right at the start, Jordrell Bank. How on earth did that come about?
Oh yeah, that's my awesome project. Yeah, that's my 4 minutes of fame. Yeah. How that came about was I was doing some voluntary work through the IET, Institution of Engineering and Technology, and through that, IET was one of the original partners on the BBC Microbit project, and the BBC had put a call out to the various partners saying, we've got this idea. We've had a contact with, because they did, was it Stargazing or Star Watch or something? There was a BBC programme that was, because up in Manchester, just down the road from Manchester. And the BBC had good links with Jordrell Banks, so the new Professor Tim O'Brien, I think it is there. And they just had this idea of doing a massive project, but they didn't have anyone to do it. They didn't have anyone in-house that had the experience of the Microbit and all the other bits and pieces. And they just put a call out to all the partners, says, is anybody interested in giving this a go? And, me with my wizard hat on, I wasn't called a wizard then, but thought, yeah, I'll give it a go. And again, a lot of that was done virtually over the internet. And then we had three separate days. I went up to Manchester and we filmed a thing and got it working. And that, I suppose, that was pre-Bitio days, probably pre the book day as well. So that was the first real time we had multiple Microbits talking to a Raspberry Pi on a collaborative project. And in those days, the Microbit didn't support radio or Bluetooth. So we did it with 3 USB cables. So I suppose it was a wired version of what Bitio does today.
Yeah.
So it was a call for, they just put a call out, say, does anybody have, the skills and interest in doing this? And I was the one that didn't sit down. So, it was good fun. It was a really great project.
Was it a case of, I'm going to regret this?
It definitely, it was. But I really, really enjoyed it. And there was, what I really say, I mean, it was really, really fantastic working with both the Jordrell Bank people and BBC. And we all really, really desperately wanted the thing to work properly. And it did really work properly. There was no smoke and mirrors behind the scenes. We really did tilt that Microbit, and it really did move the Lovell telescope. It took us a few hours to get the thing to work. So you see a 4-minute segment on TV. But that was several hours of pacing the floor trying to work out why some network message wasn't working, but it did work. It was great.
Going back to the radio capabilities of Microbit, what's the effective range of it?
Oh, okay. So the physical layer is in terms of the radio spectrum it uses, it is the bottom half of Bluetooth. It's just the peer-to-peer radio doesn't use the top protocols, so it's like a very, very trimmed down Bluetooth. What that means is, and I think there was a question earlier in Martin's segment, Bluetooth does a whole load of clever stuff with frequency hopping to get good resilience and good range. So if it's sending a message and the message doesn't get through, it will change to another channel automatically, and that may have better performance. And there's various measurements that does. Myself and Martin Woolley, so Martin Woolley was also involved in the Microbit project. He wrote the Bluetooth binding for the Microbit. We both did a whole load of range testing independently and got similar numbers. He wrote it all up on his blog. I managed to, in an open field, get nearly 300 meters line of sight. Wow. With the radio. What we found was if you have anything in the way, then that significantly reduces. So if you're holding the Microbit and then you turn around so that your body is in the way between the two radios, then it tails off really, really quickly.
Yeah.
He, with Bluetooth, he managed to get a little bit further than that. And I think it's all documented on his blog. And I think that's more because Bluetooth has a lot of extra stuff to do with resilience, with the frequency hopping. In a classroom, I mean, sometimes, you get it through the walls, it will just about reach through the walls to the next classroom. So we've had some kids that have done like remote temperature sensing of rooms and things, and they built their own little repeaters to get the range, but it varies. They advertise, 10 meters is a good range to use it for. So fine for a robot. I mean, you wouldn't want to be upstairs in the pit controlling a robot downstairs on the track. You wouldn't get the range because there's too many people in the way.
As fun as that would be.
Yeah, as fun as that would be. Yeah, literally do it by remote control. Camera feed and things.
Stand on the balcony and just.
Yeah.
One more question. Just the Microbit version 2.
You
had a chance to play with it yet? What did you think?
Yes, I was. Fortunately, I was on. So I was when the Microbit version 2 idea came around. I was on the ideation team.
Right.
I was working at Microbit Foundation then. Subsequently, I'm doing other stuff. But the guys got in touch with me and said, we've got this exciting new thing. Do you want to sign an NDA and have a look at it? And so I got one of the version 2s very early on before it was released. And a couple of the launch projects on the launch webpage of mine. So I did the Hold Your Note and also the Parrot, the Mimic Microbit. Those are my 2 projects. Yeah, fantastic device. I think what's really important to say about it is that the team have worked so hard to keep it backwards compatible with everything that's already working, because they knew that teachers wouldn't want to change how things are working, and humongous amount of effort went into keeping it compatible so everything just works out the box, and some really, really clever multi-mode hex file things that they come up with. The speaker and the microphone, it's super great fun to work with, and the device has got more memory. So there's been some experiments, and they're talking about putting some machine learning on there. So there was an experiment where they showed a machine learning model they loaded on, and they trained it with a whole load of people saying "Hello, Microbit." And they did this live at an event, and then someone holds up the mic and says "Hello, Microbit," and it responds. So that's I think going to be really, really encouraging for the future. So I think there's more to come, but it's a really credible device, and the fact it's got more memory. I think that we'll see people do more with the Bluetooth on it, because we can load a larger stack now onto it.
Yeah. Well, okay, I think that's all the questions. Oh, wait a minute, we've got one more question. Is it possible to get information from the robot to the controller, so going the other way?
Oh, yes. I just see that. That's our friend Musab. So I must just give a really super shout out to Musab, because Musab is recently became one of the contributors to Bitio. So he submitted a pull request and did some setup changes for me, and I accepted those. So really, really great to see Musab joining in from Turkey. Yes, it is. So the radio feature was actually it was a contribution from someone in the community. So I'd left a little placeholder to say, this is probably how you do radio. And someone did it. It was a teacher, actually, and accepted the pull request. So that's how we've got the robot controller working with Bitio. So the radio works both ways, and Bitio supports both ways. So yes, what you could do is you could send a message from the Pi, and literally you just say radio.send. So in your Python code on the Raspberry Pi, you say radio.send, open quotes, message, and that message appears at the controller. And then because you've got the code that runs on the controller, and it's just MicroPython code, you can do anything with that. So one of the things you could do, for example, is you could send battery status. I think Musa has put some example getting data of distance sense, and you could do So you could send data back to the controller. So it's a really, really good way of doing it.
That's really cool. Well, thank you for answering all those questions, and thank you for doing the talk, because I know doing the talk is half the problem when you're recording it, not doing it live.
Yeah.
So thanks, David. Really do appreciate it.
Yeah, really great to see you again, Mike. Take care.
See you. Bye.